We're going to begin solving trig equations today. We actually kind of already looked at this a little bit with that IXL that you guys had in M10, but we'll be looking at ones that have more than one step to them today. The first thing I want to talk about is principal values. So trig equations are going to have infinite answers. For example, you can see right here, if I have the equation sine of theta equals 0. Well, sine of theta equals 0 at pi, also at 0, also at 2 pi, and then if I kept going around the unit circle, 3 pi, and 4 pi, and 5 pi. So the answers would go on and on and on and on and on forever. So usually trig equations are restricted to a given part of the unit circle, and we will be looking at today restricting those to principal values. So principal values are different depending on which function you're dealing with. If you are dealing with sine and tangent, then it's going to be negative 90 degrees to positive 90 degrees, or negative pi over 2 to positive pi over 2. And we're going to try to work mostly with radians to get ourselves more familiar with those radians. This is the first and the fourth quadrant, but be careful because it's from negative 90 to positive 90. Values that fall in this fourth quadrant here have to be given as negative angles, not as, for example, you would not say 330 degrees. You would say negative 30 degrees instead. For cosine, the principal values are from 0 to 180, or 0 to pi there. That's going to be your first and second quadrant. All right, so here's our first equation that we have to solve. Sine of theta plus 1 equals 0. So this is not a lot different than what you were doing whenever you were doing those problems from IXL. You are just going to solve this so that the sign is by itself. So you would just subtract 1 from both sides. So you are looking for where sine of theta equals negative 1. So you're going to look on the unit circle. Because this says principal values, all that means right there is that for sine, those principal values are from negative 90 to 90, or I want you to do these in radians here. So negative pi over 2 less than or equal to theta less than or equal to pi over 2. So we're only looking at this section of the unit circle. And we are looking for where sine equals negative 1. And sine is our y-coordinate, so that happens right here on the unit circle. This is 3 pi over 2 on the unit circle, but we don't want to give 3 pi over 2 because that does not fall between negative pi over 2 and pi over 2. Or think like 270 does not fall between negative 90 and positive 90. So instead, we're going to think of the negative angle here, which this would be negative pi over 2. So we're going to have theta equals negative pi over 2. And that would be our answer for number 1. For number 2, we're supposed to solve for principal values. This time we've got a cosine function, and we're solving for principal values. So that means we're looking from 0 to pi. So we're looking for values 0 less than or equal to x less than or equal to pi. So we're only looking at the first and second quadrants of the unit circle. And we're just solving this for cosine. So we would add 1 to both sides. So 2 cosine theta would equal 1. And then we would divide both sides by 2. So cosine of theta would equal 1/2. So we're thinking to ourselves, where on the unit circle does cosine equal 1/2? So whenever I look at these, cosine equals 1/2. Cosine's our x-coordinate right here at pi over 3. And that's the only place on this section of the unit circle. You'll notice that cosine also equals 1/2 right here at 5 pi over 3. But that is not a principal value because we're only looking from 0 to pi. So our answer here would be that theta equals pi over 3 there. Okay, here's our next one coming up, and we're supposed to solve for principal values again. Tangent. The principal values for tangent are negative pi over 2 less than or equal to x less than or equal to pi over 2. I guess I should use a theta there, but it doesn't matter too much. So I'm going to subtract 4 from both sides here. So I've got 4 square root of 3 tangent of theta equals negative 4. I'm going to divide both sides by 4 square root of 3. And so tangent of theta is going to equal negative. Actually, here the 4's are going to cancel each other out, so I'm going to have negative 1 over the square root of 3. But we know that everything on the unit circle has been rationalized, so we're going to need to multiply the numerator and denominator both by the square root of 3 here to rationalize that denominator, and we'll get negative square root of 3 over 3. Now, tangent is much more difficult because we were looking for where tangent of theta is going to equal the negative square root of 3 over 3. So, for this, we've got to think about those points. First of all, I know I have a negative square root of 3 over 3. So for that to happen, I have to have a positive sign and a negative cosine, or a positive cosine, negative sign. I've got to have opposite signs for sine and cosine. So our answer is not going to come from the first quadrant here. For tangent, we're looking here in the fourth quadrant. And I see that there's only 2 places here where I've got that square root of 3. So it's either going to be negative pi over 6 or negative pi over 3. So if I think of tangent of negative pi over 6, which is right here, it's the same as 11 pi over 6. That would be sine over cosine, which is negative 1/2 over square root of 3 over 2. If we divide the fraction, easy as pie, flip the second and multiply. The 2's will cancel here, and we'll get negative 1 over square root of 3. If we rationalize that like we did right here, we're going to get negative square root of 3 over 3. So our theta is going to be negative pi over 6. Now, if that had not worked, then I would have tried tangent of negative pi over 3 to see if I got the right answer there. But tangent of negative pi over 6 worked, so I'm going to stick with it. Okay. For example 4, we've got tangent of theta times sine theta plus 1 equals 0. And so what we've got to think of here is sort of like if we had something that was factored, like x times x plus 2 equals 0. Because this equals 0, we can use the zero product property, which means we can set x equal to 0 and x plus 2 equal to 0. So this is factored here, and we're just going to set each factor equal to 0. So we've got tangent of theta equals 0 and sine of theta plus 1 equals 0. So for tangent of theta, where this equals 0, this means sine of theta over cosine of theta has to equal 0. And for that to happen, sine has got to be 0. Cosine cannot be 0. Remember, for tangent, principal values are the first and fourth quadrants. So here, this happens right here at 0. Sine of tangent of 0 would be 0 over 1. So we're going to have theta equals 0 for our answer for this part of the equation. But we've got to also do this other side, so we'll have sine of theta equals negative 1. So we're looking for where sine equals negative 1. We're in the first and fourth quadrants right here. Right here is where sine equals negative 1. It's 3 pi over 2, but again, we want to use the values from negative pi over 2 to positive pi over 2. So we are going to say that that is negative pi over 2. And so 0 and negative pi over 2 would both be answers for this problem. For a problem like number 5, we've got cosine squared theta minus 1 equals 0. So cosine squared theta would equal 1. And so remember, this is cosine of theta squared. So if we want to get rid of that square, we could square root both sides. When we do that, we're going to have cosine of theta equals, remember when you square root both sides of an equation, you have to put the plus or minus with your answer there. So we're looking for where cosine is either positive 1 or negative 1. Now, principal values for cosine are 0 less than or equal to x less than or equal to pi. So first and second quadrant here, cosine equals 1 right here at 0. So theta equals 0. And then it can also equal negative 1, which happens right over here at pi. So theta can also equal pi. So we would have two answers for number 5. Okay, number 5 is a problem that I find really tricky sometimes. Now that I've seen it several times, it's easy to me, but it certainly was very difficult when I first learned how to do this problem. So you can't really combine sine and cosine. You can't factor anything out. I'm going to move, excuse me, my cosine over to the other side, and that gives me sine x equals cosine x. And so I can't really solve that, but I can stop and think. I'm looking for where sine equals cosine. And so when sine equals cosine, I'm looking, in this case I've got sine and cosine, so my principal values could be the first and the fourth quadrant, or also the first and second quadrant. We're going to find the answer falls in the first quadrant, so it doesn't become important which one we're looking at here. So I'm looking for where sine equals cosine. So like here, sine is 1, cosine is, cosine is 1, sine is 0. So that's not the answer. For pi over 6, cosine is 3 pi over 2, sine is 1/2. Those are not equal to each other. But right here at pi over 4, cosine is square root of 2 over 2 and sine is square root of 2 over 2. So they're equal to each other right here. So x here would equal pi over 4 because that's where sine and cosine are equal. Now, for principal values, we're looking either first and fourth or first and second. The only place this happens right here is in that first quadrant. Now, you do have this point over here at 5 pi over 4 where sine and cosine are equal to each other. And if they had asked us to look at the whole unit circle, we would include that answer also. We'll see more of that whenever we go over this on Monday as well. But for right now, we're just looking at these limited sections. So pi over 4 is our only answer. So that covers what you need to know for your homework that you're going to do for me. So you've got 10 questions here that you're going to work out. You can write it on notebook paper, take a picture of it, and upload that to Canvas for me. If you're having trouble or you have questions, what I want you to do is I want you to try something on every problem. Try to do something there. And on Monday, if you have questions or unsure about something, I'll call out the answers and we'll go over any that you guys are having trouble on.